an electric field which is given by Ampere's law. And that induced electric field, how can we relate it to the change to the magnetic flux? Huh? So, decrease in current reduces the magnetic field, it causes decrease in magnetic field. Decrease in magnetic field induces decrease in, produces decrease in flux, and because of the decrease in flux, if you consider the free charges on this on the inner cylinder, there would be an induced current. So that induced current is the result of an induced electric field, and we say that induced electric field E, if you integrate it over a closed loop, that must be equals to negative d pi by dt. So this electric field for the inner cylinder is going to be tangential, and that electric field, what does it do to these charges? If you have an electric field, then these charges will experience an electrical force. So you have a force that's tangent at every point of this cylinder. So force crossed with, if you cross the position of each charge with that force, then you get a torque. So the same thing is happening for the charges outside. So let's find this electric field. So this is not an external electric field, this is induced electric field. So E induced for the inner, so for the inner cylinder, E induced times, what should be 2 pi A must be equal to change in flux with respect to time. So E induced 2 pi A equals to minus d by dt. So what's going to be the flux? First, how can I express the magnetic field here? For S less than R, what should be the magnetic field? It's the solenoid. It carries n number of turns per unit length, and the current is I, so how can you express the magnetic field of mu naught n times I inside? What about outside if it's long? 0, right? So that's your magnetic field. So for the inner cylinder, then the flux, the B field is constant, and the direction should be what? Z hat, right? Towards 0. So how can I express this magnetic flux for this inner cylinder? Pi A squared times whatever B field you have, that's mu naught n I. So what's changing in the current? So what we get here? E induced is going to be minus of pi A squared mu naught n di by dt over 2 pi n. Or this provides that here is equals to pi plus pi. That's going to be minus a minus mu naught a n over 2 di by dt. And what should be the direction? should be, the electric field is tangential, it should be in the field, right? So if you want to express it, vector notation. Just to convince yourself why this has to be in the negative d direction. Remember, the flux is decreasing, right? So the induced magnetic field should be directed to hold the decrease, you need an induced magnetic field in your direction. So that's gonna be in the positive z. So to get current, to get a magnetic field that's pointing towards you, the current due to the induced field must flow in the positive v direction. I have a minus sign because I express di by dt. So I is decreasing, so you have a minus sign from that, so that would make it plus. Does that make sense? All right, so that's the induced electric field. Now, what about for the outer cylinder? For the outer cylinder, 0. Okay, let's start from here. Okay, this, what should I? Okay, E induced, so then we call this one inside, inside, and inside. So this is going to be outside. So the dl is going to be minus d by dt of the flux. So what should be the flux now? Remember, I'm finding the flux through this. Yeah, we don't have any magnetic field in this region, right? But we do have a magnetic field that extended from the origin to here. So I should write the area as pi times r squared, because we have a magnetic field over this entire area. So pi r squared times, well, it's uniform, so mu naught n. Mu naught n I. So here, what should I write? E induced out times what? What kind of closed loop are considering here? 2 pi b, yes. So 2 pi b equals 2 minus d. Carry out the differentiation with respect to time, I would have minus pi r squared mu naught n di by dt. All right. So what you find then is going to be minus pi r squared mu naught n. Well, pi cancels. Mu naught n over 2b di by dt. And so this is also in the v direction, right? But remember, the charges outside are negative, and this electric field should be plus. Okay, the flux is decreasing, so
I was going to be decreasing.
well, yeah, I think it should be in the same direction.